This is the Building Automation Monthly Podcast with Phil Zito, episode 182. Hey folks, Phil Zito here, and welcome to episode 182 of the Building Automation Monthly Podcast. And in this episode, we are going to be talking about cybersecurity and building automation systems. Now, in an upcoming episode, we hope to have Fred Gordy on, who is an expert in cybersecurity, and have him discuss kind of what he's seeing on the consulting end. I myself have a master's degree in cyber defense, and I have a background working on a lot of technology projects, so I as well understand cybersecurity, and I'm going to take it from a different angle than Fred's probably going to take it in a upcoming podcast episode. I'm going to look at it as kind of a 101, and then in the future podcast episode with Fred, I hope to cover implementation. All right, so in this episode, we're going to dive into what is cybersecurity. We're going to talk about attack vectors. We're going to talk about the difference between site cybersecurity and OEM cybersecurity. We're going to talk about securing a BAS. We're going to talk about the attack vectors, talk about internal, external attacks, and I'll give you a bunch of reference sites that you all can refer back to. Because I find this whole topic seems to be overwhelming for a lot of folks. It's one of those things that feels like a giant elephant, and you're like, how do I consume this gigantic elephant? Well, there's that saying, you consume it one bite at a time. And so that's what we're going to start in this episode. As always, our episodes are sponsored by our online training courses, and this episode is sponsored by our Information Technology for BAS Professionals training course. Now, if you are a building automation professional, which I assume you are because you're listening to this podcast, and you realize that building automation is becoming increasingly IT-centric, and you're saying to yourself, I need to learn this IT stuff, but I don't have time to go back to school. And there's so many different programs out there that are specialized on networks and databases and servers, and they're all specialized towards IT. How can I find something that will teach me exactly what I need to know about IT from a building automation perspective in the quickest amount of time possible without me having to travel and take a bunch of time off work? That is where our IT for BAS Professionals course comes into play. I encourage you to check it out at buildingautomationmonthly.com/182. Scroll down to the IT for BAS protocol, or IT for BAS Professionals. We also have a protocols course, but I got those mixed up there first again. Scroll down to that logo, click on that, and find out more about our IT for BAS Professionals course. All right, so cybersecurity. What is cybersecurity? So you hear the word cybersecurity, and I want you... don't do this if you're driving, but I want you to just close your eyes for a second and visualize what that word means to you. If you're like most folks, you close your eyes, you visualize cybersecurity, and you think of hackers. You think of people attacking your building automation system, sitting in a dark room somewhere in Russia or wherever, and hacking in, right? Well, cybersecurity is not just hackers. It's much more than that. It is securing cyber assets. So what are cyber assets, right? So cyber assets are technology assets, network assets, things that utilize cyber technologies. So when we think about building automation systems, it used to be they were just a bunch of field controllers with a supervisory device, and they had their own little kind of standalone internal network. No one really logged into them. The computers sat in a closet somewhere. We didn't have a whole lot of concerns. But now, as we start to expand our technology, as we start to look at cloud technologies, as we start to look at IP controls, as we start to enter this world of IT, we have to start considering cybersecurity. And for a lot of OEMs and for a lot of just building automation contractors, this whole cybersecurity thing is very overwhelming because we are entering a technology market. Here's the perspective I want you to think about, right? For the longest time, we were at like 1960s technology. I mean, we weren't vacuum tubes and things like that, but we might as well have been. We had these gigantic panels that took up entire rooms, and That stuff's still running in some places. Folks on some of the Facebook groups are posting pictures of that. And so we've got that. And then we've got these OEMs out here who are bringing about, web-based controls, IP controls, cloud-based computing for our controls, all these technologies. So we have leapfrogged into what I would say is, 1990s IT technology. All the marketing out there makes it seem like, oh, this stuff's so freaking advanced and amazing. When in reality, embedded controls on IP are things that have been around for quite a bit. Cloud's been around for quite a bit. Virtualization's been around for quite a bit. It's just we as an industry tend to lag technology by 10 to 20 years, and we're just now catching up. The problem is we're catching up, but the whole cybersecurity and the whole ecosystem of just threats and cybersecurity providers and all of that is so much further freaking mature than we are. We're like Stone Age, and they're, in modern age. And we're catching up rapidly. You see OEMs who are starting to actually take cybersecurity as a important point of their offerings, mainly because some vulnerabilities detected in their software, as well as owners are now expecting that because that's what consulting engineers are telling them to expect. And so you see this whole thing about cybersecurity is becoming important. But that's just one little piece, right? So we're so focused on this hacking and got to keep our systems cyber secure, but we don't really think about it's much more than just defeating hackers. It's about securing the technology that the building automation system is requiring in order to be functional. So we're going to focus on that largely in this episode. After all, what threats really exist against a BAS? So I went to the Google and I typed in cybersecurity for building automation systems. And you start reading and you get all the usual folks commenting, and you get the manufacturers who provide cybersecurity services and products, painting a doom gloom, the world is horrible, and half of them don't even know what we do. I'm not talking about building automation OEMs. I'm talking about folks in the cybersecurity world. I'm looking at one thing from a cybersecurity provider, and they're talking about PLCs, and they're saying in your building automation system, you need to protect your IoT device cameras. And I'm like, do you guys have any freaking clue what we do actually in building automation? All right. I don't know what advisors and consultants these companies are talking to, but whoever they're talking to is not advising them on what the building automation industry actually is and what we actually do. So there in itself is part of the conundrum, right? Is trying to figure out what threats are real and what threats aren't when you have these folks who have a vested interest in you thinking there's a threat, telling you to do things that aren't really viable because they don't really even understand what you do. All right? So let's talk about what threats really exist. And in order to do that, we have to understand a couple terms, right? First, we have to understand an attack vector. You'll hear this term in cybersecurity circles, and the attack vector is the method, the approach, the entry point at which hacker or an attacker. It doesn't have to be a hacker. It doesn't even have to be an attacker. It could be an accidental attack, an accidental issue, as we'll see later in the episode. Those are the points at which it all begins, okay? So an attack vector is where it all begins, and ultimately an attack, whether it be intentional or unintentional, is going to affect one of three things. There's this concept called the CIA triad, and that stands for confidentiality, integrity, and availability. Now, the reality is the majority of what we do in building automation, we don't give two flying flips about confidentiality. We are not sending information that we really care if someone else knows. If you know my zone temp set point, I really don't care. If you know that my air handler's running, it does not matter. What we're primarily concerned about is integrity and availability. Now, integrity is a huge one, right? Integrity and availability, I will say, are equal, but integrity can affect availability, whereas availability doesn't really affect integrity. Okay, so integrity is making sure that the data, that the commands are actually the right commands that were issued. So this is an area that a lot of folks are concerned about, especially with BACnet, because BACnet is an unsecure over UDP protocol, a protocol that basically is in plain text oftentimes. And the fear is, since it's a connectionless protocol in a lot of cases, even the sync ACK can be interrupted. Sync ACK, I'm talking about, confirm ACK, whatever it is for confirmed property requests, confirm request ACK. And what I'm talking about there is like if you submit a write property request and then it will confirm back, or if you do a read property request, it is a confirmed request and it'll confirm back. Well, what I'm talking about there then is this integrity. If you are able to interrupt those write property or read property requests, then what's going on is you could have a command to turn the chiller on and you actually turn the chiller off. Or you could go and close valves while the chiller's running, take down a central utility plant to a data center. These are all issues that could occur and could cause problems. Okay, so that's all well and good, and that's bad, right? It's not well and good, actually, it's bad. But then you also have availability, okay? So we have availability, and availability is quite simply the availability of the system, right, of the building automation system to be accessed, right? It's available, it's up, it's uptime, it's running, everything's all well and good. So if integrity is data being manipulated and availability is things being up, I mentioned integrity can impact availability. Now, at this point, some of you might be tuning out. You might be like, oh my God, what the heck is Phil talking about? You can't freaking do that right now. You've got to pay attention, because if you don't understand what I'm teaching you right now, I can teach you how to secure a BAS, but it's not going to mean crap because you don't understand why you're securing it. You don't understand the concepts behind it. You don't understand what's a real threat and what's not a real threat. You're going to be duped by anyone out there who has credentials and is saying, I'm a cybersecurity expert, and they're telling you to do stuff that doesn't freaking make sense because you don't understand these core concepts. So I'm telling you, don't tune out. Pay attention. This stuff's important. All right. So integrity, right? That is making sure the points are right, making sure our commands and our reads are all good. Availability is making sure stuff is up. Integrity can damage availability, because if you can go and make equipment go down, you can make it not available. All right, so it makes sense, right? Great. So all that, we've got our attack vectors, we've got the CIA trad, and then we've got this thing called OAM Security. You know, it was always the hardest thing for me to go and sell software upgrades and patches and stuff like that to our customers. But nowadays, that cybersecurity is more of a concern for owners, and OEMs are taking it seriously. They are rolling out patches, and so they are largely responsible for the cybersecurity of products' internal configurations. Now, I want to repeat that real quick. The OEMs are largely responsible for a product's internal configurations. How does it handle HTTP? How does it handle HTTPS? How does it do encrypted logins? What's the authentication process? How is communication traffic encrypted? How are certificates managed, et cetera, et cetera? That stuff you can't change. Okay, you cannot change that. You can go and make sure an IP address is, secure behind an ACL and firewalls and all that jazz. You can use a different form of authentication like LDAP, things like that, and that's all well and good, but that's on top of this OEM security. Now, OEMs, they go and often go through a process nowadays, they didn't in the past, of securing their systems. They'll often do external testing, both white box and black box testing of their systems, and if there is a security issue found, they will often fix it before you're even aware of it. And if there are issues that are found that they weren't aware of, those often will go into the ICS CERT website under a CVE, which is Common Vulnerability. What is that acronym again? Let me remember. Yeah, common vulnerabilities and exposures. That's what I thought it was, but I just wanted to double check that. And that will be on ICS CERT, and they'll talk about CVE, and there's a whole rating structure to it that I'm not going to get into. It's pretty clear on their site anyways. But you can look up manufacturers and see what vulnerabilities they have in what version of their software, how it affects things, and what the recommended fix is. Now, granted, software is software, and I mean, there's, depending on who you ask, there's so many bugs per line of code, and there can be issues in hardware and software, and you could be completely unaware of them. And so that's something that I recommend like once a year, just checking ICS CERT, understanding if your product's in there, and then if it is, what do you need to do to reconcile that? But what we really got to focus on is how can you secure a BAS? Well, there's really three major attack vectors for building automation folks, right? The first is the network, right? So network has multiple attack vectors: public IP addresses, not putting stuff on VPNs, not protecting access to ports, having all the ports open, et cetera, et cetera. Then there's the application, right? Not using hardened passwords, everyone using the same password, all those kind of things. And then uptime, okay? So uptime is making sure that the building automation system's up through, redundant power, and making sure the server's not sitting under someone's desk or right under the coffee maker. I actually saw a freaking coffee maker sitting on top of the BAS server with the server laying on its side. It was one of those desktop servers, and it was laying on its side, and the freaking coffee maker was sitting on top of it at this university, which shall not be named. But that was straight up comical. I mean, this building automation systems controlling the HVAC in this pretty large, I'm trying to not identify them, pretty large university, and there's a coffee maker on the BAS server. Okay. Anyways, you guys, I don't think I have to worry about that with. So as far as these attack vectors, I like to break them into internal attacks and external attacks. So the internal attacks, they're pretty much the low-hanging fruit, and they're the things you really should just take care of up front. So threat number one, in my opinion, based on my experience, and this probably contrasts to a lot of cybersecurity experts out there who will tell you, the number one threat is making sure your system isn't publicly exposed to the internet, because then everyone can try to attack it all the time. Well, in my opinion, the number one threat is server uptime and failover. If you're building automation servers not up and running, it doesn't matter if its IP address is secure or not secure, because it's not running. So making sure it's not sitting in a broom closet, making sure it has a UPS on it, ideally utilizing virtualization like we talked about in last week's episode, to make sure you're going and keeping the building automation server up and running. These are all things that are really important and are so easy to do. So easy. Stick it in a rack, in an IDF with redundant power, and make sure that it's actually a virtual machine and can fail over to another virtual or over to another physical server as a virtual machine in the case that that IDF goes down. I mean, it's so simple to do. It's really not hard. Number two threat, and you all know this is done, so don't tell me, I've never seen this done before. And this is password sharing and single user login. You go to the facilities, folks, and they're like, can't we just make it facility, username facility, password facility? No, that's a horrible freaking idea, because that exposes you to so many things, right? For one, Which person was logged in when the issue was created? I mean, we talked about accidental attacks earlier. What if someone goes and changes a bunch of set points or uses a mass edit and deletes a bunch of objects? I mean, that is essentially affecting the cyber readiness of that product, right? It's no longer functional and ready. So by going and sharing accounts and sharing passwords, you have no accountability of who's logged in, when they're logged in. You have no way of regulating login. Let's say some disgruntled employee quits and goes somewhere. Well, I mean, there was a hospital where I think it was Allerton, maybe it was a Tritium system. I don't remember. I'm pretty sure it was an Allerton system. It honestly, it really doesn't freaking matter. It could be any system because the issue was not with the system. The issue was with that they had bad user right control. So the security guard had access to the BAS system, and he had a password, and he had access to everything, and he was changing a bunch of set points and all sorts of stuff. And then he got fired, and I think he continued to do some stuff after he got fired. So password sharing and account management is huge. Make sure you go and resolve that. And I'll talk through methods of securing all of these in just a second. And then finally, data and system manipulation. So folks coming in, manipulating data, manipulating the system, changing the data, etc., changing set points, deleting controllers. So all of this can be resolved pretty easily, right? Server uptime and failover, put in a virtual server, make sure that it fails over to another virtual server, make sure it's in an environment where it's physically separated from one another. So if a fire happens in one building, it doesn't affect all buildings, right? So take care of that. Password sharing, make sure you're using unique usernames and passwords for each individual. And finally, data and system manipulation, make sure you're using not using a single, make sure you're using multiple different user access layers that are appropriate to the level of access you want to have the user having. So you don't want the maintenance folks having the same level of access as the controls engineer who's actually designing the database and designing the architecture of the building automation system. So regulate those. Now, external attacks. This is where everyone in our industry seems to focus. And this is what pisses me off, right? I mean, this really upsets me. I get that external attacks are a focal point. I do not dismiss that. I do not dismiss that we should be focused on external cybersecurity of our systems. However, in my experience, working on hundreds of systems and talking with thousands of students who have also worked on hundreds of systems, the majority of the time we have issues with our building automation system. It is an accidental attack, an accidental issue, and it's related to those three kind of things I just listed out. I can count on a single hand the amount of times I have heard of external attacks damaging building automation systems. Now, folks will quickly rush to point at SCADA systems and power plants and things like that. Those are not building automation systems. I get that they are kind of like the same thing in parity in that they are embedded controls. And I also acknowledge that there are systems that have been attacked. However, I'm saying if I had 40 hours in a week to allocate my focus, I would focus first on those internal issues prior to focusing on external issues. So, hope that was clear in my focus point and in where I see these as far as ranking of importance. So, external attacks. What are external attacks? Well, the most common ones are going to be attacks that take advantage of the network, attacks that take advantage of the application, okay? And then we're going to have attacks that take advantage of the person. Okay. So, and these aren't ranked in any order of occurrence or order of severity. It's just literally the order that when I was doing the show notes and planning this out that they popped in my head. So first is network. So now here we're talking about a publicly exposed IP address. We're talking about not utilizing VPNs, not properly segmenting controls networks from the public network at a university, all sorts of things, right? And the threat is that someone can see the building automation system, and we already know that backnet traffic is open in clear text. Someone can see the building automation system. They can manipulate the traffic. They can go affect the traffic, and they can really affect the building automation system just through an availability and an integrity attack of manipulating data, man-in-the-middle attacks where they intercept data traffic and then alter it, all sorts of things like that, right? So methods of securing are pretty straightforward. Utilizing VPNs in order to go and access your building automation network is a quick and easy fix for a lot of solutions. Properly implemented, a VPN will go and essentially make your BAS seem like it is a internal only network. And when you need to access it remotely, you use VPN software that creates an encrypted connection, and it allows you to extend the external network to your machine. Now, nothing's foolproof, and if your machine's been compromised and all that, then, VPNs are useless. But in most cases, a VPN is a great approach to network security. Rather than having that public IP address and worrying about that, you just have a VPN that passes through the internal network to your BAS segment, which is another thing. BAS segments, making sure you segment your BAS network. Now, I'll be honest, having the BAS be accessible through the Wi-Fi is pretty freaking awesome when you're in a campus environment and you've got to go and work on the BAS and you're right next to an access point. You're trying to configure a VAV controller or a fan coil controller, and you're in the ceiling and you got your laptop and you're working on things because you don't want to plug directly into the controller. Because you want to see kind of some other variables that maybe in other systems are impacting them, especially VAV troubleshooting. And so you're sitting there and you connect to the Wi-Fi, and that's awesome because you don't have to be wired to anything. Now, on the flip side, that could be a problem because even if you hide your wireless access, you keep it as an unpublished wireless network, people can still find it. But once again, physical networks, wireless or wired, they still have things you can do in order to secure them. So you can go and ensure that, hey, for this external or this internal external Wi-Fi network, you can make sure that only certain devices can connect to it. You can do all sorts of network security things that we just don't have time in this episode to get into. So I said, right, the first one is network. The second threat is applications. There's really not a whole ton you can do to applications other than deleting the default username and password, making sure you use certificating, making sure that you have VPNs implemented so that folks aren't publicly accessing your network and interrupting communications. But most of the application cybersecurity is handled by the OEMs. That's just the reality. It is mainly their responsibility to manage their software. They should give you the recommended settings based on their security threat analysis on how they want you to securely implement their applications. But it is their mission and their job to maintain the security of their applications as long as you are meeting the recommended implementation guidelines. So they should be providing you guidelines on how to implement their applications securely. But once you've done that, that should reasonably address the cyber threat. They can't guarantee the addressing of every threat. That's not reasonable. But, it should address a reasonable amount of threats. Okay, so we talked about our networks and application threats. Now let's talk about person threats. Now, one of our most famous threats and attacks that is quite often referenced is the whole Target attack with the Fazio Mechanical and the quote-unquote building automation attack, which a bunch of folks were like, oh, it's a building automation attack. See, building automation, cybersecurity. When in actuality, it was a phishing attack with someone who had improper credentials to access a part of the network that they should not have been accessing. Actually, it wasn't that they shouldn't have been accessing. They should have just been segmented better. So the issue with personal attacks or people attacks, and this is one of the better ways to attack our industry. I don't know if I should be saying that, but The reality is we're not the most tech savvy industry in the world. We try to make ourselves out to be, but I mean, I stand in rooms teaching folks about IP controls, and half the room doesn't know what an IP address is. And I'm not judging anyone. Don't get me wrong. I am not on a high horse sitting there pointing my finger going, look at you. I'm just saying the reality is we are a mechanically oriented industry, and we need to accept that. And the sooner we accept that, the sooner we can go and start training the gaps. And one of the gaps is, even understanding what phishing is, understanding what phishing emails are, we all think that it comes in the form of the Nigerian prince who has $1 billion and he just needs you to send him $10,000 and then, he'll free up his money and he'll pay you too. No, phishing attacks are much more subtle than that. A lot of times research will be done. And the attacks these days can look very sophisticated. They can look very similar to real emails. And because of this, you have to train your folks, both your customers as well as your own personnel, on attacks that can take place. Because technically, if you aren't properly implementing a cybersecurity program and your devices get attacked and your people get attacked and compromised and do damage to your customers, depending on the state you live in and the country you're in, you could be liable. And, cybersecurity laws are ever changing. And so I'm not even going to pretend to be a lawyer. I don't represent or provide legal advice, but I will tell you that laws are definitely getting more in the favor of folks who are the people who are the result of an attack or are affected by an attack, and they are becoming much more damaging to the people who didn't prepare their own employees to be able to defend against an attack. So that's something that is just training. There's really not a whole lot you can implement other than training and processes. If people are requesting passwords or requesting you to install certain applications or services and, they're masquerading as your OEM's technical support group, you need to validate that. Just hop on a phone and ask someone. So a lot of information was covered in this episode. I hope this my fear with doing this episode was that it would just make you feel worse about cybersecurity and you would feel like crap. There's just more crap that I need to know and I'm already overwhelmed. I'm just going to put my head in the sand. I'm hoping that you come out of this episode and you're like, you know what? This isn't as bad as I thought it was. Those internal attacks that Phil talked about, I can really see myself going and implementing some security measures around those. That seems reasonable. And then I also understand the responsibility level my OEM has as far as security, and I'm going to be more demanding on them of educating me on what I need to know about the security level of my products that I purchase from them. And so that's what I hope you take out of this episode. And as always, I'm freely available for you to reach out in the discussion board, or if you're watching this on YouTube, to go to the comments below the video and ask me whatever questions you have. I'd love to answer them for you. And, hopefully we'll get Fred on in the next couple weeks, and he'll provide more of what he's seeing on the consulting side. And I think he'll provide a really good tempered perspective because he comes from the mechanical world as well. So it's always good to have folks who actually know what the hell we do talking about cybersecurity. So with that being said, thanks a ton for listening. As always, tune in. Every week we'll be doing an episode on something, and I really enjoy having you all here. Thanks for the reviews. Thanks for the comments. Go to buildingautomationmonthly.com/182. I'd love to interact with you there. And be sure to check out our IT course if you are at all finding yourselves not where you want to be with information technology. This course will get you where you want to be as fast as possible. Literally, it will get you where you need to be faster than any other program out there in the marketplace. Until next week, thanks a ton for being here. Look forward to talking to you all again next week. Take care.